Hi, this is Introduction to Statistics covering 1.1 and 1.2 from the textbook. We're going to start off with a couple quotes. So our first quote is coming to us from Mark Twain. Facts are stubborn, but statistics are more pliable. This captures maybe kind of a commonly held belief that statistics can be manipulated to say anything we want them to say, to back up whatever our position might be. And this is true to some degree, which is one of the reasons it's really important to study statistics and know what to look for to determine if a statistic or a study or some research that you are presented with is valid or not, whether it has been developed, created using proper statistical procedures. It is true, statistics can be used to manipulate, but that doesn't mean all statistics are manipulative. Another quote, purportedly from Abraham Lincoln: 93.2% of all statistics you read on the internet are made up on the spot. Obviously, he could not have said that, and that goes to prove the point that is in this quote, that many times statistics that we come across really are made up and do not actually have data or proper statistical methods to back them up. Particularly online, but also things that we read in other kinds of media, things that we might come across in advertising or on the news. Okay, one more quote. Statistics mean never having to say you're certain. So this is actually true to some degree. We can never be 100% certain when we do statistics. That's sort of built into the process, the statistical process. But it has a degree of being false as well, because doing statistic actually requires that we do have some measure of certainty. It might not be 100%, it might be 90%, might be 95%, might be 99%. But good statistics require that we have this measure of certainty to go along with whatever the statistic is. So we can conclude that if we're 100% certain, then we're not doing good statistics. And if we don't include some measure of certainty, we're also not doing good statistics. So I'm going to amend this quote to say statistics mean never having to say you're 100% certain. Okay, here's a brief definition of statistics that we'll work with. It is the study of and process of collecting data, summarizing data, and generalizing from that data about the population. So it's broken into three pieces. We're going to kind of dig in deeper and look at a statistical process. So if we start in that upper left, we have a population, a collection of objects, individuals, or measurements. And first step is to collect data. And that gives us a sample, a subset of that population. That's going to be lists of numbers, lists of facts, maybe images, pictures, videos. It's going to be all sorts of kinds of data. We have to summarize that. That summarization gives us one branch of statistics called descriptive statistics. And then here's that certainty piece that is required. When we assess that uncertainty or assess the certainty, either way we want to look at it, that's going to give us the other branch of statistics called inferential statistics. That's what allows us to make some kind of generalization about that population that we started off with. We can kind of have sort of a summary statement, we can come to a conclusion, we can make a decision based on those inferential statistics having to do with that population. So let's dig into these pieces individually. Population, we want to have a well-defined population. And a population can be a collection of objects, measurements, or individuals. And it's in any case, it's what we're wanting to study, what we're wanting to know more about. So some examples, it might be all the trees in a forest. Okay, that could be a lot of trees. Or all birds in a particular ecosystem. Or all participants of a triathlon, all semiconductors produced by Intel, all individuals worldwide. All right, if we want to think of the population of the entire world, all George Fox students, all patients on a hospital floor. These could all be populations that we're interested in knowing more about. Now, if we do collect data from an entire population, that's called a census, although this is rarely ever possible to be done. So, more definitions. Now, we don't need to know everything about the members of our population. We only want relative characteristics, and we call those variables. They're characteristics that we are interested in knowing more about. So a variable is just a characteristic whose value can change from one member to another in a population. And a variable can be something that's described with a number, and we call that a quantitative variable, such as hours of sleep that you got last night, the number of siblings you have, the distance it is to the closest store from where you are right now. Those would all be quantitative variables. And then there are things that can be described by words or categories, and we call that qualitative variable, where the value is a category rather than a number. So your favorite movie, okay, that's not going to be a number. It's going to be, you're going to answer that question with words. The state that you live in, the color of your hair, all examples of qualitative data. Okay, so we've got a population and we have variables. So what do we do with that? So let's take an example of population, a small population, all Summer Math 240 online students. So that's all of you watching this video. And there's 20 of you, so very, very small population. And let's say we're interested in the variable number of letters in the last name. So that's a quantitative variable, okay, because it's a number. Now let's give another definition. It's a parameter. Now this is a number that's used to describe or measure a population characteristic. So the key there is a parameter goes with a population. And it's a specific number, but usually we do not know what it is. And we can't know what it is exactly because our population is so large that we can't get data from every member of our population. Okay, so it's a number, it's an unknown number. So if you're asked for a parameter, you're not going to answer with a number. You're going to answer with what kind of parameter it is. And the two that we will look at the most are mean and proportion. Those are the most common. Those are the ones that we're going to study the most of in this course. So the mean is the average of a quantitative variable. Okay, we're familiar with that. Proportion, another thing we can call proportion, is a percentage. Proportion is the percentage of a value taken on by a quantitative or qualitative variable. So proportion can describe either type of variable. So let's take the parameter of population mean. So again, we have population of all Summer 240 online students. Our variable is number of letters in the last name, and we're looking at the parameter of a mean. Okay, so here is the population data values for number of letters in the last name. I'm able to list out from each member of the class the number of letters in the last name. Okay, so they're listed there for you, and then we can calculate the mean. We know how to do this. You take the sum of all those values, you get 138, and then divide that by the number of values, which there are 20, and do that division, and we get 6.9. So 6.9 letters is the mean number of letters in the last name for this class of Math 240 online students. Okay, so now 6.9 in this case is a parameter value, which we don't usually know. And because the population is so small, we actually, in this case, can. So if we don't know it, that's what we want to estimate. We want to come up with a really good idea of what that number is if we're not able to know it. Okay, so keep that in the back of your mind as we keep going through. Now let's look at proportion, the parameter of population proportion. So same population, this time let's look at a variable of year in college. So this time the parameter is going to be proportion of sophomores. So a year in college is a qualitative variable, okay, but we're going to be able to come up with a numerical measure of this qualitative variable by finding a proportion. So we take the number of sophomores, which there are 6, and we put that over the total number of 20, and we get 30%. So the population proportion of sophomores in Math 240 online is 30%. Again, it's a parameter value. We usually do not know this, but we're wanting to estimate it. So populations are usually really large, much larger than 20. So for example, in the US, there's 16 million US college students. So if that happens to be our population of interest, there's no possible way to get data for all of those students. So we have to come up with another way. Okay, the other way is to collect data from a sample. A sample is a subset of our population. And then from that sample, instead of calculating a parameter, which always describes the population, we calculate a statistic. A statistic is a number, and it is going to be either a mean or a proportion based on the sample. And that is what we use to estimate the corresponding population parameter. Okay, so we can not necessarily know the parameter, but we can estimate it using a statistic. Okay, so statistic goes with sample, parameter goes with population. Okay, so we got to talk about this process of collecting data, which we call sampling, and it results in a subset of the population, and we get lists of qualitative and quantitative data after we do this sampling. So let's talk a little bit about the ways that we can sample. Our goal is to get a representative sample. So one that's that's a cross-section of our population, that it has overall the same characteristics of the population of interest. So to get that, we have to have a random sample where all the members of the population have an equal chance of being selected into the sample. Now, the best way to do that is to use some kind of computer random number generator. That's not always possible. So we're going to look at some methods to help make that happen. What we want to avoid is what we call convenient sampling, where we just sample from members of the population that are easily accessible. This results in bias. So for example, if my population of interest was all George Fox students and I used this class of 20 as my sample, well, there would be all those other students that had zero probability of being collected in the sample. So that would create a lot of bias, and I would not have a sample that represented all George Fox students.